FeatureCAM now has the ability to smooth the azimuth and elevation axis independently of each other using one of several smoothing options. One such option is the new stepped stabilisation smoothing. This type of smoothing will stabilise the rotary axis movement by maintaining a fixed tool axis as much as possible within an angular range. The toolpath will appear as a series of 3+2 axis segments with 5 axis transitions between them. The transitions can be either completed on the surface or with a lift. In this example you can see we've got this right angle shaped block part, and in this case we're going to machine a pencil toolpath using a lead lean around the inside corner. The first toolpath we have is a pencil type toolpath that has no smoothing. If I go ahead and do a machine simulation, it's going to do a single step, rotate this round, and I'm going to play the simulation. So here you can see we've got a lot of rotary axis movement as we work our way around. Then we have this tight internal corner, and in this case you can see we get a gouge. This is because the holder has collided with my part. If I go ahead and continue to play this, we can see this as it rotates. You can see the pink areas on the model that tell me where the collision has occurred. To correct this, the first thing I'm going to do is apply a smoothing distance. To turn the smoothing on, I'm going to go to the pencil toolpath, and under the 5 axis tab we check the option tool axis smoothing and press apply. We then get a separate tool axis smoothing tab, and in this case I've not applied any kind of smoothing correction, but I've just added a blend distance or a smoothing distance to help me in the transition between this region. If I go and turn my collision checking back on and replay that machine simulation, so we've still got the rotary rocking motion across the back of the part, but now we've got a smooth blend between those regions to correct that internal corner. We're now going to take this a stage further and look at the smoothing options. So the first one, we're smoothing both the azimuth and the elevation with links. If I go to the smoothing, you can see stepped with links, and we've chosen that from the pull down menu here. We're doing the same for both the azimuth and elevation. We're also adding a maximum angular correction of 50 degrees, so this means that we will correct the toolpath orientation in both the azimuth and elevation by up to 50 degrees change in that orientation position. We can also override the smoothing coordinate system, so I can use a different coordinate system, and this will dictate what is considered to be azimuth and elevation. If I preview this toolpath, I'm just going to turn off the shading, rotate round and just do an Alt F3. So a tool comes into position, and you can see it's maintaining now. We're not rotating the stock around, so it's maintaining that orientation. Then as we get to a corner, the tool will lift off the part, so you can see the lift, rotate round, and then re-engage the part at the new orientation. You can see this repeated around the component. So it lifts off, indexes round, and repeats. We can see the lifts around the component now on the toolpath. If we look at this on the machine, again I'm going to do an Alt F3, so tool comes into position. Note we're maintaining this 3+2 axis orientation. We're then going to lift off, so we lift off the part and index round. Lift off and index. We can continue this round. like so. The final toolpath is using the other option. So under the axis smoothing, this time I've got stepped on surface. So this will keep the tool in contact with the surface as it makes those transitions. Again, if I do this as a centerline simulation, I'm just going to play this all the way through. You can see we don't have the lifts on the corners anymore. If I do this as a machine simulation, we can see the tool is always in contact with the material. So we get the transition. Trying to minimize the rotary motion of the table as we work our way around the part.